We are going to create a new CSV-based resource for data exported from the HR information system that will be created from scratch. We can display more information about each screen in the internal help system, which can also contain links to the public Evolveum documentation. We define the name of the resource and continue to the connection parameters. With the CSV-based resource, we need to specify the file path. If the file is located in a specific midPoint directory, all we need is the file name. We then initiate the connector discovery process, where midPoint retrieves the configuration parameters suitable for the selected CSV file content from the connector. Next, we validate the resource schema. In the case of a simple CSV file, there is only one object class representing the accounts. We will save the resource now. We can preview resource data to verify the connection to the CSV file. We can also display attribute statistics for the CSV file content. This can be very handy when creating attribute mappings later. The next recommended step is to configure object types. The configuration can be created manually, or we can let midPoint suggest the object types using AI. We can review the suggestions and see that midPoint has classified the accounts into employee and contractor accounts based on the value of the emp-type column in the CSV file. Following this, we review the object type suggestion for employee accounts. We can change the suggested configuration, for example, the display name of the object type. We can review the suggested object class and / or filter. We can review the midPoint object type that will be related to the object type. In our case, we want to create midPoint users from the CSV data of the HR resource. We will also specify that the users should be created with the built-in person archetype, which can be later used for birthright access rights. We can continue the employee account object type configuration. The next recommended step is to configure synchronization. We can proceed manually, or we can let midPoint generate the appropriate synchronization configuration suitable for either a source or target system. In our case, the HR resource represents a source system from which we want to import the accounts to midPoint. The next recommended step is to configure mappings. The configuration can be created manually, or we can let midPoint suggest the mappings. In our case, we are interested in the inbound mappings to map HR attributes to midPoint user properties. We can review the suggested mappings and accept the ones we need. We can display the statistics of the resource attributes to better understand the patterns in data. It can help us to validate or refine the mappings, or to define custom mapping expressions. For example, there are exactly 3 values for the status attribute representing an employee's state. We can accept the suggested mappings one by one. We can also dismiss all remaining suggestions. If some mappings are still missing, or they were not suggested, we can ask midPoint to suggest the mappings again. We accept the last missing mapping. Based on the attribute statistics, we can configure the mapping expression as a script that maps each specific status value from the HR resource to one of the supported values of midPoint's lifecycle state property. There are predefined functions in midPoint, so you don't need to reinvent the wheel. We will simply map 3 values from the HR resource to 3 other values in midPoint. For the job attribute, we can see that the HR values contain a numeric job code followed by the hash character and the job title. For our purpose, we only want to take the job title part. We can use another predefined function in midPoint to only take the substring following the hash character as the job title. We can save the inbound mapping configuration and run a simulation to see what would happen. As we can see, midPoint would create 40 users. We can inspect the simulation data to see detailed information about to-be-created users. User properties and their values populated by the mappings are displayed. We can see how midPoint would create users for former employees using the specific lifecycle state archived. The simulation results are fine. We are ready for data import. We will change the resource's lifecycle state to active. We will create a new task to import employee data from HR resource to midPoint. The import task is running. As we can see, midPoint has created user objects for all employee accounts, and their accounts are now linked to the users. Clicking the resource owner shows the user data as it has been created in midPoint by the import task. We will create a new LDAP resource to integrate an existing target system. We define the name of the resource and continue to the connection parameters. With the LDAP resource, we need to specify at least the host, bind DN, and bind password. The LDAP bind password can be specified as a value or by using a Docker secret. We will initiate the connector discovery process, where midPoint retrieves the configuration parameters suitable for this specific LDAP resource from the connector. We then validate the resource schema. In the case of an LDAP system, the predefined list of 4 object classes is usually enough. We will save the resource now. We can preview resource data to verify the connection to the LDAP server. Just like with CSV systems, the next recommended step is to configure object types. The configuration can be created manually, or we can let midPoint suggest the object types using AI. This time, we will specify the object class for LDAP in @org_person. We can review the suggestions. This time, the accounts have been classified into employee, service, and administrator accounts based on the value of the base context, directory subtree. We will review the object type suggestion for employee accounts. We can change the suggested configuration, for example, the display name of the object type. We can review the suggested object class, filter, and / or base context. We can review the midpoint object type that will be related to the object type. This time, we will not specify an archetype. We can continue the employee account object type configuration. The next recommended step is to configure the correlation of existing data to midpoint users. We can configure the correlation manually, or let midpoint suggest the correlation. The suggested correlation configuration is based on a personal number. Before accepting the configuration, we can simulate the correlation. We will run the correlation simulation on all employee accounts. The correlation simulation shows 37 correlated and 2 not correlated accounts. We can inspect the accounts that were not correlated. These accounts have incorrect or empty personal numbers. We can postpone the decisions for these 2 accounts by marking them as correlate later or even do not touch. Midpoint will simply ignore these accounts from now on. The marks are displayed in the account details. We will accept the correlation configuration as it can match the majority of our LDAP employee accounts. Midpoint will create a corresponding inbound mapping for correlation purposes. We can save the correlation configuration, and Midpoint will suggest how to configure the synchronization configuration. Again, Midpoint can generate the synchronization configuration as appropriate for a non-authoritative target system. The next recommended step is to configure mappings. The configuration can be created manually, or we can let Midpoint suggest the mappings. In our case, even though the LDAP server is a target system, we want to create an inbound mapping to import the UID attribute to Midpoint's name property, which represents the Midpoint username. We will create this mapping manually. We save the inbound mapping and run a simulation to see what would happen. The simulation results indicate renamed Midpoint users. We can see this change in more details for each user. The simulation results are fine. We are ready for the reconciliation with the LDAP system. We will change the resource's lifecycle state to active. We will create a new task to reconcile employee accounts from the LDAP resource with Midpoint. The reconciliation task caused the LDAP accounts to be correlated and linked to their owners in Midpoint, and the Midpoint usernames are now populated from LDAP's UID attributes. The uncorrelated accounts remain unprocessed until later. We can now configure outbound mappings for LDAP employee accounts, as we want Midpoint to become authoritative for the LDAP resource. We let Midpoint suggest the mappings. This time, we will ask Midpoint to not use AI, and only use heuristics. We can inspect the suggested mappings. The most important one is the mapping for the LDA-PDN attribute. It will be constructed using the Midpoint user name property and the suffix derived from the real data. The mapping for UID is generated as week, so it will be used only during the account creation and not during renames. The LDAP server will handle this internally. We can accept and save all the suggested mappings. We will simulate the outbound mappings now. We can see that midPoint would change some resource objects. By inspecting the details, we realize that midPoint is about to replace the values that differ from the midPoint mapped properties, which actually originate in the HR system. In our case, all these changes can be explained simply as corrections of previously incorrectly provisioned LDAP accounts.